Hi everyone, this is Basu and today I'll be showing you a very common use case of home automation. We have a edge device, which is basically the device in the entire system, which is a Node MCU. We have the middle layer or the MQ here. Since we are using MQTT protocols, so we are using MQTT broker. We can even use IoT hub, which supports MQTT protocol, but currently we are more focused on the broker instead of. On the other end, we have a controller, a mobile app. So basically, it's like controlling a electrical load, like a ceiling fan, by using a mobile app. It's a very simple use case, and lots of work have already been done. Let's see what exactly this system or this architecture follows. It is also very much evident that this edge device, it is a Node MCU, is connected to an electrical load by a relay circuit, interfacing circuit. We'll discuss about the relay and the circuitry a bit later on. So in the architecture, we have a Node MCU which is connected to the MQTT broker using the MQTT protocol, and we have a controller, dashboard, or app, whatever you may call it, which is again connected to the MQTT broker. Now this MCU and controller subscribe to the same topic. That's how the message transfer is taking place. Moving on further to the MQTT, like what exactly this is. So we have a MQTT broker. Now there's a topic. Let's say the name of the topic is Subvido. Now my device, that is a Node MCU, is subscribed to the topic, and my mobile app is also again subscribed to the topic. Now this message exchange happens by the means of publisher and a subscriber. If my MCU is a subscriber, then whenever I'm publishing message from a mobile device, that is a mobile app, to that topic, the MCU receives that particular message which I have sent. Similarly, in the other side, when I'm sending a message from an MCU to the device using an MQTT protocol, the mobile app is already subscribed to that topic, let's say video, and whenever I publish some kind of message from the MCU, the data is received from the mobile. So it is a very lightweight communication, which is totally lag free. It doesn't require huge amount of data. Implementation is also very easy. There's not much of interfacing is also not required. You just need to have a MQTT broker, and even there are lots of free available MQTT brokers already available in the internet. You can use that also. One of the most common example is, if I remember, is iot.eclipse.org. I'll come to everything about the MQTT later on. So this is the overall architecture of the entire system. So we come to coding aspect of the Node MCU. In the previous section, we have already discussed about the MQTT protocol, the concept of topics, and MQTT broker. Here we are going to discuss the entire code, like how we are hooking up everything into a single platform. There are a couple of libraries that I have used: the pubs client library, the ESP826 Wi-Fi.h, and the Wi-Fi manager.h. Now certain parameters that are to be noted at the MQTT server, which can be iot.eclipse.org. The port number, which is 183, the topic, out topic for sending message from MCU to the device, that is the controller, and the Android/Edison is another topic which is used to receive incoming messages from the controller to the Node MCU. Next, we have declared the MQTT server. In these lines, we have declared some couple of global variables and message buffer, and instantiated all the objects. In void setup, we have initially configured all the pins to output mode. We have set all the pins to high, which is actually low in case of a Node MCU. We have initiated a serial port communication. We have declared a Wi-Fi manager. Now this Wi-Fi manager library is again developed by a person named Zapu, and it's developed by a person named Zapu, and it helps us to remotely configure the Wi-Fi credentials in a Node MCU by a mobile. Initially this Node MCU becomes a hotspot. We open our mobile, we connect it to the hotspot, and then HTML page pops up. We enter the credentials of the Wi-Fi, SSID and password, into the HTML form, click on the submit button, and those credentials get saved to the Node MCU's EEPROM memory, which can be retrieved at a later stage. Like if I'm using my home Wi-Fi right now and I switch up the Node MCU and again switch it on, I don't need to manually configure it again, because it just retrieves it from the memory and it connects itself. So pretty much it's a very useful library, what I have found out as of now. I have set up the Wi-Fi manager.autoconnect Node MCU. This actually sets a hotspot's name if in case it needs to become one. I have displayed some couple of messages. You can or may not use it, it doesn't really matter. What matters are these two lines where I have set the server for the MQTT protocol, MQTT underscore server, comma port number 183, and I have set a callback method. Now this callback method is invoked whenever there are some kind of incoming messages. Like if I'm using a Node MCU, yes, I'm using a Node MCU. Like if I publish some kind of message from a mobile app, then this callback method is invoked. In this callback method, where it gone? Yeah, in this callback method, I'm handling all the incoming messages. I have also performed some condition checking. Based on the message received, I am writing perform digital write operation on the pins. I'm setting the pin to high. Yeah, it's actually high, because setting a pin to low is actually high in case of a Node MCU, because of the pull up resistors combination, I guess. Next, in this reconnect method, we are actually connecting to the MQTT broker. I've used a randomly generated client ID for the Node MCU to connect to the MQTT broker. Once it gets connected, it will publish a message like, yes, I am online, in the topic out topic. Now after publishing it to the topic, I am subscribing the Node MCU to the topic Android/Edison, such that whenever a message is popping up in Android/Edison topic, the Node MCU will receive that message. Now, yeah, this is all about the reconnect method. Above one was of the callback method. Now, when you're using MQTT protocol, you need to have a callback method and as well as a reconnect method. Reconnect method is not essentially like, it's not like you have to do it, otherwise it won't work. But to stay on the safer side, it is recommended to implement the reconnect method. In void loop, I repeatedly check in like whether I have lost a connection or not. If I have lost it, I'll just use the reconnect method again. This will initiate all the process, and here I'm just sending a message to out topic like, hey, I'm alive, followed by a value. Now this value is basically incremental value. It starts from 1 and it will end until it gets a max value. That's how the entire code is working. So basically we have a void setup where initially we have configured all the pins. Next we connect our device to Wi-Fi, followed by we initiate the MQTT protocol, we set the server, followed by the port number, then we initiate the callback method. In callback method, what we do is like we publish a message initially, I can hear like I'm alive and all this sort of stuff. But the main purpose of the callback method is to receive all those. Sorry, I think I have told wrong. In callback, we don't handle we don't publish any message, but you can publish it. The main reason of using the callback method is to receive all the incoming messages. In reconnect method, we initially publish a message and we also subscribe to a topic. Then in void loop method, we start the whole process and we publish some kind of message in out topic at regular intervals of time. That's how the entire code is functioning. I'll open up my mobile device where this is the, just close it. Yeah, this is the MyMQTT app. So this, I use this app to test all my MQTT based projects. So initially you need to go to settings tab, mention your server URL. You can also mention the port numbers, but by default it's 183, so we don't need to mention. If you have a username and password for the MQTT broker, then you need to mention over here. Click on the save. Now go to subscribe, add the topic you want to subscribe to and click on add. It will automatically be added over here, and I have subscribed to Edison/control and out topic. I think this, hold on, how did I disappear this? Yeah, Android/Edison is there and out topic is there, because I'm using out topic to publish the messages, and out topic is used by the mobile to receive the messages, and Android/Edison is used by the MCU to receive the message from the mobile. So I go back and, sorry for that, I'll just go to a dashboard. Here you see that I'm receiving the message in the topic out topic. This is the incremental value, and I'll just open the serial monitor, parallel open this also. I'll just make this disappear. Yeah, so I'm sending all the message, and all the messages are coming over in the dashboard. And suppose I want to publish some kind of message, I will just write the topic name Android/Edison. I write the message @group 171. I publish it, and I receive the message over here. So this is actually a terminal for the Node MCU. I'm using, like, whatever message I'm receiving, I'm dumping it to the serial communication, and I'm seeing it in a serial monitor. And if I go to dashboard, I just use my mobile. See, I have @group 171. So that's how this entire code is functioning. It's pretty much simple. There's nothing much complicated in it. It's just necessary for you to know the concept and how it is all functioning. In this section we will see, like, I won't go into the full details, like what are the steps they followed and all those stuffs, since this tutorial is not meant for configuring the virtual machine, but I'll just give you a glimpse and overview, like what exactly I have done. So I have used Windows Azure to set up my virtual machine. You can use Amazon Web Services or IBM Bluemix, anything which you want. Since I have free credits in Windows Azure, that's why I'm using Windows Azure. So I created a virtual machine instance of Windows 10, and it has already provided me with a DNS name. And there's one more thing that you need to keep in mind, like I just click on this, click on the endpoints. You need to configure the endpoints. That's a very essential step of configuring your VM to support connections globally. So we have one endpoint for remote desktop, we have one for PowerShell, and we need to create one for DNS, the TCP protocol, which is hosted on port number 183. Since our Mosquito client is also hosted on 183, that's why whenever we mention the server URL, it's hexacontrol.cloudapp.net, it is redirected to this. I will just open the virtual machine. You can download, like if you are planning to create your own virtual machine where you want to set up your MQTT broker, then I will suggest you to go through this article. I'm not the owner of this article, but I find this article quite resourceful for the person who want to set up the MQTT broker on a Windows machine. So if you go to mosquito.org, so I think I spelled it wrong, I guess. Yeah, I think I spelled it wrong. It will be just hold on. Yeah, my internet is pretty much slow. So once you go to mosquito.org, there you have to download the Mosquito client for Windows. But once you download that, you will find some couple of dependencies. Yeah, so it has opened. So once you download your Mosquito client, you will get a couple of dependencies. So you need to install those additional DLLs which is required to set up the Mosquito client on a Windows machine. So once you get a hold of those DLLs, you just need to install it and it will run automatically. I will show you. I go to my virtual machine. MyMQtt, just click on this. So it's as already mentioned, it's a Windows 10 instance. If I go to command prompt and if I type, after all the installation, if you type netstat -an, so if you just go up a bit, you should be able to locate something at port 183. Should be something like 0.0.0. Yeah, this is the one. This is the one that is Mosquitto client is hosted on. Now if I click on services, that is services.msi, there you will see Mosquitto broker version 3.1 is already running. So once you have installed your Mosquitto broker on a Windows machine or on a Linux machine, you can definitely go for Linux also. There's on Ubuntu based, and after you install a Mosquitto broker, it will run as a service at the backend, and by the use of this endpoint, we can remotely access it. I think my computer freezed. Anyway, yeah, so you can remotely access by the use of this DNS email. Now again, you need to manually add this endpoint. It is not always there from the beginning. So for adding the endpoint, you need to click on add, and just click on this button. Here you need to select a value like DNS and protocol TCP, the public port and a private port. Then if I click on the tick icon, then it will get saved. It takes some time for like deployment and etc. I'll probably make a video like explaining the details and how exactly I can configure the entire thing, but this part of this entire video was just to mention like it is possible to host your MQTT broker on your own server, and by the use of port forwarding, you can just make it global such that anyone can access it. Yeah, there are security issues also, because just go to this. There's a configuration file that is present. My virtual machine, because of my internet, is pretty much laggy out here. See, my mouse is also frozen. I'll just edit it. Open with Notepad. I think Notepad is not installed. By default, we don't get many things. So once you open like this configuration file, can be used to set up the user ID, the password, the port where the Mosquitto client is hosted, and so on. So basically, if you want to set up your own MQTT broker, I would suggest you can definitely go for Azure, since you get $150 credit initially. So once you set up the MQTT Mosquitto client or MQTT broker, then you can definitely use it for your own projects. So we have come to the penultimate section of the entire project, which deals with this hardware circuitry. So we have a Node MCU which is connected to the relay, and the Node MCU receives power from a mobile charging wall unit. You will see the picture. This is a wall unit which I was mentioning about. So this Node MCU is connected to all the control pins of the relay module which I have used. Now this relay module you can either buy as a whole module of relay units, or you can just buy individual blocks and make your own interfacing circuit and expose the control pins and VCC pin and a ground pin to be controlled by other devices, be it a Node MCU or Arduino or anything. Here it's a Node MCU obviously. So we have the digital pins of a Node MCU, that is D0, D1, D2, D3, D4 and D5, which are connected to the control pins of the relay. Now this control pins, actually like this D0 and D4, these pins are like numbered on the Node MCU board, but in the real case it's actually like GPIO 14, 16, 0, 2, 4, something like that. The map was shown before in the coding section. So these relay units have 3 ports. That is normally open, normally closed and common. Now if your relay is on, then the port that will get activated is a normally open and common. Those two will be shorted. So yeah, those two will be shorted. Yeah, correct. Now if you are using a normally close and common, then when the relay is switched off, then normally close and common are shorted. Else when the relay is switched on, normally open and common are shorted. Again, there is one more thing to consider, is like these relay modules operate on the basis of electromagnetism. That is, when we excite the electromagnet present inside the relay module, the switching happens based on the excitation. That's how it occurs. I'll just make it disappear. Okay. Now the circuitry that I have used to connect the relay with the electrical load, and here you may also note one more thing, that I have used a mechanical switch as well as a relay unit. So those two switches can operate parallelly with each other. So if the mechanical switch is on and the relay won't be operational. Now if the relay is on, then the mechanical switch won't be operational. I have did this kind of configuration such that if there is no power of, if or above all, if there is no internet connection, then I won't be able to switch on the light, which I don't want. So that's why this is the mechanical switch is kept as a backup. And when I deployed this home automation system in my home, it was actually for testing purpose to see whether everything is working or not. However, I have not yet fabricated the entire board, which I will do it at a later stage after continuous testing process. Now we this is a look. It might look a bit messy, or you can say very messy. I don't know, whatever you call it. So we have a Node MCU that is connected with the mobile adapter unit. Now this wire goes to the mobile from the mobile adapter unit to the Node MCU. Now these are the control pins. That is from D0 to D5. These wires go inside the relay module. Now this white box contains the relay. From here, the relay module have the wires connected to the main switch box. Now when I switch on this Node MCU power outlet, there only the entire system is functional, else it's not functional. However, you may replace this mobile outlet with a 3.3 volt battery pack. In that case, you have to, let me see if I can decode something. You have to connect the positive end of the battery pack to this pin, that is this 3 volt. If you can see the pointer, my mouse pointer, then this 3 volt you have to connect, and negative to ground, this 3 volt and ground. And the relays that is the VCC 3 volt should be connected to this 3 volt and ground. Okay, so that's how the entire circuitry is working. However, you may fabricate the Node MCU along with the relay module in a single PCB and make it as a black box kind of structure with a few inlets and a few outlets. However, this was done in just a day to for me to like perform some test during long hours of operation. Till now my Node MCU is tested for around 72 hours of continuous operation, and I haven't faced as of now any heating issues, neither with the relay nor with the MCU. It's I will say it's very dependable as far as home automation is concerned. Yeah, so we have come to a demo section of the entire video. Here I will be showing you that on the left hand side of the screen you can see my room, and on the right hand of this right hand side of the screen you can see my the projection of my mobile device. So I'll open the app, which was developed solely for the purpose of controlling. The design of the app's credit, like the credit for the design of the app goes to Saktish Jadeja, who has helped me a lot in designing, because I didn't have much of an idea about Android. So I took his help in designing the UI and everything. However, I have used the Eclipse PAHO library for communication using the MQTT protocol using this app. So when I'm switching on the light 1, the light 1 is switched on, but you can see the delay, right? So delay is not because of the MQTT connection, but because I'm using an older version of the tube light. However, you won't see a delay when I switch on light 2. So when I switch on light 2, say it switches on instantly. Now you can see the fan, right? Which was shooting, but I switched off. But I am switching on the fan because it's too much heat out here. So when I switch on the fan, there is also no delay. So that's how this entire thing is functioning. Now in this app, you can click on this gear icon to set all the parameters, that is the MQTT server URL, the port number, and the topic to which it is required to be subscribed or to publish. So once you click on save, I'll just go back, switch on the light, fan, light 2, I switch on again just for your purpose, light 1. So we have come to the end of this entire video on home automation. However, this is not typically a home automation because we are not automating anything. We are just shifting the control from mechanical switches to an app-based functionality. Typical home automation can be considered only when you are automating it. That is, we don't need to control it. However, like if we simply walk into a room, the light should get switched on. Typical use case will be the use of PIR sensor. However, we can perform more complex computational algorithms where we can bring in AI to the picture. This is just, I hope I am able to cover most of the basic concept of controlling our home. Thank you for watching this video, and if you like this video, please hit the like button. I'll be uploading more videos on IoT, robotics and embedded systems. Please hit the subscribe button if you want to see like this kind of videos more, and thank you again. Meet you soon.